It's been my distinct pleasure to work in wireless for 10 years. So for the first 8 years, I was actually working on the controller-based wireless LAN. So I worked on all different parts of the controller-based wireless LAN, the hardware, software architecture.
Can you speak up just a little?
Sure. Hardware, software architecture, adaptive radio management, per user firewall, remote AP, all those functions. Got a chance to work on all that. For the last 2 years, I think a small team here has been working on what we call virtual controller-based wireless LANs. So the first question that comes up is, why should Aruba do virtual controller-based wireless LANs, right? Because we've been selling controller-based wireless LAN. It took us IPO. We're a good company. We're competing with Cisco. But I just want to give you a little bit of idea on how access point hardware has evolved. So before there was Linksys WRT54G, there was a very small US robotics modem, US robotic access point. So in 2002, that was the hacker's paradise for a US robotics access point. And that was the first access point that we used to build Aruba technology. And the specs on that access point, it had a 1 meg flash, it had 2 megs of DRAM, it had a 33 megahertz CPU. It was a single radio 11B access point. So that's kind of in early 2002. So now, the last access point that we shipped, which is the AP135 access point, now that is a dual radio AP, which is 11N 3x3. It has 16 meg flash, 256 meg DRAM, and a 1.6 gig CPU. So access point hardware has kind of followed the Moore's law curve.
Can you repeat that? Those specs?
Yeah, sure. 16 meg flash, 256 meg DRAM, and a 1.6 gigahertz CPU. So the idea is that access points over the last 8 to 9 years have evolved in hardware. And what we have noticed is that for a class of networks, it is possible for us to take all the controller technology that we built over the last 8 years, which is provisioning, configuration, image management, per user firewall, role-based access control, adaptive radio management, and it can be virtualized into an access point. So that's what kind of we realized about 2 years back, and the last 2 years we've been working on what we call the virtual control architecture, which result in the Aruba Instant product. So what I want to do is, I have no slides, so if it's not interactive, it won't be fun. So what I want to do is, I just want to give a quick demo of the UI, and not talk through how to create a network or what are the 10 features we have, but just kind of show you what is the thought that has gone into the UI, show you some small features. And so we'll kind of do that for 10-15 minutes, and then kind of talk about what is the thought that has gone into the architecture of the product and all the features the way we have built it, and how we took the controller technology and built it into the access point. So this is a network that is running in the other building, and there are users that connect to this. There are about 11 access points in this network, 2 or 3 mesh points. So the first thing that you will notice is that when we looked at this UI, if you look at any networking device, it's basically a task-based UI. You have configuration, you have monitoring, you have troubleshooting, you have diagnostics, and then all the UI is kind of built on those tasks. But what we realize is that the majority of the time what administrators are doing is they're monitoring and troubleshooting the system. So if you look at this, it is focused on monitoring and troubleshooting, and all the other tasks are embedded into the monitoring and troubleshooting systems. So from left to right, what you will see is that, so this is the virtual controller, and this is a set of networks that are being advertised by these access points to which these clients connect. This UI is completely HTML5 based UI, because around the same time when we started building it, we had a requirement, iPads are coming out. So from the beginning, we had a requirement that the UI has to work seamlessly on the iPad. So every access, please.
Is there any way that you can make the font larger? Even my young eyes are having issues.
Okay, sure.
Do you need to sit closer?
I think I do.
You can put these in front of yours and stand on your head.
It's like just with the lights and the
Yeah.
the pale
really
font, you
washing
just
out.
can't see it.
Thank you.
Yes.
Could you zoom in a bit when you're on your screen a little bit when you're showing something?
Okay.
So that we can see it on streaming a little bit better?
Okay.
Thanks.
Is that better? Okay. So maybe, so on the left-hand side, you see networks that are being advertised by access points to which clients connected. So as I was saying that it's a completely HTML5 based system, no flash. I think Steve Jobs was great. So we actually believe in that. So big, and it also allows us to render it on different platforms. Another reason we didn't want to do flash is because you cannot, on the access point platform, it's a kind of a very optimized platform, so you cannot run heavy complex functions on the access point. You cannot load heavy access point function like a flash applet or a flash executable cannot be integrated into the image. So we went with HTML JavaScript. The other thing that we focused on is, I will talk about small things. The other thing they focused on that we wanted to build a UI that will render beautifully on an iPad, which is a 1024 by 768 system. The same UI has to render very well on a UXGA 1900 by 1200 system, and without scroll bars, because scroll bars are evil. Because scroll bars kind of horizontal scroll bars are really bad. Vertical scroll bars are a little less bad. So what this does is it actually, if you resize, it automatically kind of changes the layout. So we actually worked on this layout very well, quite a lot, to make sure that all these different things did not get clipped and you didn't get scroll bars. So the way UI is laid out is that in the bottom you get information about the object that you select on top. Right now you've selected the virtual controller. So here you get, in the RF dashboard, you get a sense of what are the clients that are having issues. So in this, it says a couple of clients have low signal strength, and what are the access points that have utilization noise or errors. And you can see the bunch of access points have very high utilization because this is running in the 1322 network, which is the engineering building where there are a lot of neighboring access points. So the duty cycle on our 2.4 gig band is very high. So another small thing that I want to point out, when we looked at graphing, we looked at graphing very carefully, because a traditional graphing, the way you graph signal strength, the way you graph noise, the way you graph throughput should be very different. So let's take the example of throughput. You see, throughput is usually very bursty. So what you want to do is you want to build a graphing system where the Y scale is actually a log scale graph. So if you see the units carefully, it goes 0, 10, 100, 1K, 10K, 100K. The reason that's important is that, let's take this client as an example that's connected into the network. There was a period of time when he did around 73 kilobits per second, but there were periods of time when he did 150 bits per second. So if you had a linear graph, what would happen is that you will see a graph that just goes straight and one peak and go down. So you will not be able to see the real bursty traffic pattern if you didn't have a log scale graph. So I just want to give an example of the kind of thought that has gone into. So it makes the system more usable. It allows you to troubleshoot easier. If you go to the bottom, one of the things that you'll notice is that we actually show signal strength and the speed right next to each other. And you will see that the y-axis is exactly aligned. The x-axis, the timestamps kind of are exactly aligned. So the reason you would do that is because traditionally in Wi-Fi, as the signal strength changes, your transmit rates goes down, right? So you want to be able to correlate the data together very well. Similarly, the frames per second and throughput are kind of aligned right next to each other, because as your frames per second increases, kind of your throughput increases. And for example, let's look at the frames per second graph. So this is on an access point. So I'll just pick a radio and do a frames per second graph. because when you're doing a frames per second graph, you want to make sure that you actually show the retries and errors merged into the frames per second graph, because you want to be able to debug that together. So this is an example of where you're seeing in and out frames per second, but in black and red you're seeing what is the retry rate, because high retry is an indication of interference in the network. The other thing to talk about, of course, is that from the very beginning we actually wanted the system to be accessible, so we actually built internationalization into the UI. So all the strings that you see in the UI is completely cataloged into an XML file, and it's very easy to convert to different languages. So I just want to give two examples of how that works. First thing is Arabic, because Arabic is right to left. So your whole UI updates and you can see everything in Arabic. So this has been a very, very useful thing, because especially when Wi-Fi becomes pervasive, it's going to go across the world. And I can give an example of a customer that I was working with in Saudi. So they wanted a very specific feature that we had to build. So we gave them the feature, and I got good response that, oh, well done. So the next day what I did was we built the Arabic language support and we gave it to them, and the response that we got was so much more positive, because it actually helps, it makes the product more accessible. Another example is Chinese, because Chinese is also a difficult language to do, because the character set is so complex. So you can see Chinese also renders very well. So we have about 10 to 12 languages that we support. So once we did internationalization, let me give an example. So the idea was, how do you pick the default language? And the easiest thing to do would have been just make it configurable. Right, it makes sense. But we didn't want to do that. So what we did was we actually picked the default language based on what your laptop default language is. So we actually identify the locale that the laptop is in, and we change the language on the fly. So I can give a small demonstration of that. So what I will do is I will kind of try to change the language on this. So what I did was I made French the default language. So it all became French. So the idea is that then you don't have to make this configurable, because majority of the time your locale you will be able to identify. Let me move it back to English, because of course I don't know French. So the other thing that we wanted to solve, so let's focus on these timestamps. So these timestamps, one of the places where Instant is getting deployed is in the distributed enterprise, where you have a lot of offices worldwide, and you might have a NOC in 2 or 3 locations. So when you're debugging a problem, sometimes in your mind you have to do the time zone calculation, because usually networking device export time in the local location that they are in, right? So what we did was we actually automatically adjust the time based on what the local time zone is, similar to internationalization. So identify what the local time zone is, automatically change the time. Let me give you a quick demonstration of that. But that also makes the product easier to use, easier to deploy, and easier to manage. So I changed the time zone to Madrid. So I think you can see on top my time on the local laptop changed to 7:56 p.m. So now if you see, all the times here have been adjusted to 7:55, 7:56 p.m. So when you're debugging, you can actually, you get the local context, even if you're debugging a remote network.
Can you disable that? So if you have non-Aruba devices, say in a switched infrastructure, or even if you're just trying to compare with a standard Microsoft Radius server, a lot of customers will just default to UTC, and that's what we use everywhere if we're a global.
So yeah, that's a good point actually, Blake. So I think the way the networking infrastructure works, it actually maintains everything in UTC. So if you go into the networking infrastructure and you look at time, you'll always get UTC. When it exports things to management system using SNMP or something, everything will be in UTC. So the UI, what it does, it actually identifies local time and does on-the-fly conversion from UTC to local time. I think I should move this back as well. So the last thing I want to show is just a quick thing on search. I think in the first release that we did, we actually did not implement search because that was the time when Google Instant had come out, and any search that as you type, if it doesn't give you result, is not useful. It doesn't matter. So any search that you do, press return, and then you get data, doesn't make sense. So this search actually does inline completion. So you can select any, if you want to look for this access point, then press complete, the access point gets selected, and you get to troubleshoot the problem. This was kind of a quick kind of introduction into kind of some of the nuances of the UI. Any questions on this? Yes, please.
So, and we kind of been talking here, this is a really great UI. I mean, and the fact that you've basically done all this and crammed it onto a tiny little AP is even better.
Yeah.
So when are you going to move it to your controllers?
That's a good question. Yeah. So that's a very good question. So let me show you something. I think that's so what we are doing.
Pradeep, can you repeat the question for the live stream audience?
Yeah. So the question was that I think the question was from Tom that I think this UI is quite good. And when are we going to move this to the controllers? And the point that I want to make is that we are actually doing it right now. So let me show you some examples.
Log into the controller. This is not the Aruba you're looking for.
So this is UI of the dashboard that we have built, right? So this UI of the dashboard follows the same principles, where you kind of get a very kind of a high-level view of the network. You can kind of identify which devices have low SNR, which have high SNR. Same with speed. If you look at the terminology, kind of is becoming consistent, and you can kind of debug your potential client issues. This is similar to the RF dashboard that we looked at in Instant, where you can see what are the clients with low SNR, what are the clients with low speed, low good put. Same with noise floor, which is, yes?
Can you just explain what good put is?
Yeah, good. So you see, in Wi-Fi there are two things, right? One is a transmit rate. So transmit rate is the over the PHY, what is the modulation I'm using to talk to you. And good put, if you want to think, when I'm talking to you, I can either talk very fast or talk very slow, or talk very slow. The good put is amount of real information that I'm sending to you. The good put would be amount of Ethernet packets that are going from you to the server. So it's the information that is getting exchanged. So we've done, we are actually migrating all the lessons that we have learned with Instant and kind of moving into the controller. We are looking at internationalization. The help system is, let me give you an example. The help system is actually integrated now. So the way help works on Instant is help is a mode. So you click on help and points where you need to see help kind of become in a different color. And then if you want to understand what RF dashboard is, you take your mouse or an iPad, you have to select it, and then you get information of what the RF dashboard is. But this same help system is kind of getting migrating to the controller. Same monitoring system that we have built in the Instant is also getting done in the controller. The only challenge with the controller is that it actually is working at a much bigger scale. So we have to do a sort of aggregated views and then kind of dig in. And what I showed you in this next picture was the aggregated views that we see in the controller. And because most of the time people spend monitoring and troubleshooting the network, our focus on improving the usability of the system is on monitoring and troubleshooting the network in the controller. So I don't know if I have to do a demo, but this Instant UI looks good on the iPad as well. Yes, please, sir.
Question. So Cisco uses CCX, right, to pull information from a client. What do you guys have? Do you have anything similar to that?
That's a very good question. So this goes back to maybe the early days, 2004, 2005, when CCX was first getting introduced. So there are two ways of innovating in any technology. You can innovate on the interface. Let me just explain it. And you can innovate on the implementation of the interface. So innovating on interface would say that you build a proprietary interface. And then you assume that the proprietary interface will give you an edge. The second way of doing it is you take the standards-based interface and you innovate on the implementation of the standards-based interface. So what CCX does is it actually innovates on the interface. So innovating on the interface kind of, I think, does not allow that technology to be pervasive. And we believe in innovating on the implementation of the interface. Let me give an example. In ARM 2.0, we built a band steering. So band steering is built on the concept that a client, when it comes in, it sends probe requests, and neighboring clients are supposed to send probe responses. So what band steering does is it takes the same interface and says every AP will not generate probe response to every client generating a probe request, because we want 5 gig capable clients to go to the 5 gig band. So because we innovate on that implementation, our algorithms work across all the Wi-Fi devices. A CCX style architecture will not work on mobile devices. It won't work on the iPad. It won't work on the iPhone because they have Broadcom clients. And the CCX style interface cannot go into every device that's out there. So we don't innovate like that. So we innovate on the implementation.
I might be getting ahead of where.
No, it's
you
it's
can
okay.
tell me. Since you brought up band steering and we kind
Yes,
of
yes,
into RF,
yes.
Can you go through what the difference is in capabilities for like ARM on an instant AP versus your controller based, and what can it do and what can't it do?
Yeah, so that was one of the things I was going to talk about anyway. So when we talk about ARM, we talk about two sets of algorithms, ARM 1.0, ARM 2.0. So ARM 1.0 as a headline influences the behavior of access point. ARM 2.0 as a headline influences the behavior of clients. So in ARM 1.0, if you might be aware, we kind of have algorithms to select the right channel and power, and our goal being maximize coverage while minimize interference. We do voice aware scanning, load aware scanning. All these features are available on Instant as well. ARM 2.0 is band steering, taking 5 gig clients and encouraging them to connect to the 5 gig band. Airtime fairness, making sure that if you have a 11N client really close by and 11B client, the airtime is fair across them. All those features are available on Instant as well.
Hey, Pradeep, can you explain a little bit more about those features, like actually how they're implemented, what they do in the AP?
Yes, sure.
Some of the technical background?
Yeah, sure. So let's start with ARM 1.0. So the first challenge that you have is how do you assign channel and power to access points. So in the simplest sense, if you talk about channel is a circle where you control the color of the circle. Power is a circle where you control the radius of the circle. Very simple. So our goal is to, as I said earlier, maximize coverage across all channels while minimizing interference on my channel that the AP is in. So what do you mean by coverage? Coverage, the way we define it, is all the neighboring APs, including myself, that are advertising my SSID. Interference is all foreign APs, like the Starbucks AP, best example I can give, or foreign interference sources. So we have a set of metrics that we compute, maximize coverage and minimize interference. So all the other ARM 1.0 algorithm kind of feed into this, because if you want to do this properly and you are on channel 1, you need to get visibility into the whole spectrum. So for that you have to scan. So by definition, when an access point radio is scanning, it can't serve clients on that channel. So you can of course scan all the time, but if you scan all the time, for example, if you have voice traffic, then you will drop voice packets and you affect QoS. So we have voice aware scanning. So the firewall on the controller and the instant access point will tag voice packets automatically based on the protocols like SIP, SVP, Vocera, FaceTime, Link, and then they will tag the packets so that when a packet comes into the access point that has to go to the client, which is tagged as voice traffic, then we will suspend scanning because we know a voice stream is coming. Next example is load aware scanning. So the idea that when the assumption is that when the network is loaded, when the access point is serving a lot of clients, that means your applications are kind of active. You want to suspend scanning if possible. ARM 2.0, I'll take 2 or 3 examples. The first example I'll take is band steering. So the simplest example, all these laptops, the way they are built is they are built to connect to the AP with the strongest signal strength. And as we all know, 2.4 gig, the signal strength propagate faster. 2.4 gig AP will always seem stronger to a client than a 5 gig AP if the distance is the same. So, but the available spectrum on the 5 gig band is much higher. So how do you do band steering? So band steering is two problems. First is actually identifying that a client is 5 gig capable. And the second problem is steering the client in the 5 gig band. So we actually have algorithms to automatically identify and fingerprint clients that are 5 gig capable. And then we actually built algorithms to steer the clients to the 5 gig band. And these algorithms actually also have gone through a couple of iterations, especially when the iPad came into the enterprise. We had to change the algorithms because the iPad is a very unique device. So you have to kind of make sure that the iPad behaves very well when you have enabled band steering in the network.
Did
Yes.
I understand you correctly when you said, problem number one is discovering if the client supports 5 gigahertz or not? Right?
Yes, yes.
And it sounded like you maybe do some sort of discovery about the card itself, like the model of card, or are you using that simply based on probes?
We are, as I said, it's simply based on probes. It's basically, we don't innovate on the interface. We interface the implementation of the interface, right? So we don't want any software on the client. That's one another rule that we have for RF management. Now we've kind of built software on client for VPN. Maybe another one to talk about is airtime fairness. So the idea of airtime fairness is that, see, TCP is a very efficient protocol. So if you have one 11N client which can sustain a PHY rate of 300 megabits per second, another 11N client which can only do 200 megabits per second, if you don't control the air, the 300 megabits client will starve the other clients because the TCP window size will keep increasing. You'll be able to pump more and more traffic because it's a very efficient protocol. Congestion control algorithms in TCP are very efficient. So, but over the air, I think it doesn't make sense. So we actually have algorithms that we have built where you can, administrator can specify policies saying they want fair access or preferred access. If they select fair access, then we ensure that all clients that are connecting to the access point get the same amount of spectrum time. Preferred access, we can build policies that says 11N clients should get more access than 11B clients. That might still be there in your network.
That's easy enough to do downlink. You control all that.
That's a very good point. So the good thing about TCP, the two good things, right? One is most traffic is downlink, and good thing about TCP is that if you control downlink, you can control uplink automatically. Any other?
There was a question on the difference between instant and controller.
Yeah. So I thought I think instant actually provides all the functions that are available on the controller for when it comes to ARM. So ARM 1.0. Intelligent channel and power selection, voice aware scanning, load aware scanning, rogue AP aware scanning, and then ARM 2.0, which is band steering, airtime fairness.
When you talk about ARM and doing channel planning and transit power planning, and you said one of the things you take into account is external sources of interference. I think a lot of us would be interested in hearing about non-802.11 sources of interference. How you get visibility into those, what you do with them, because non-802.11 sources of interference aren't about duty cycle, right? It's about, or aren't about, channel utilization. It's about duty cycle.
I agree.
And so, I think one of the things that some of your competitors are beating up on is, getting that visibility built into an AP, as opposed to using, commodity radios.
Exactly. So maybe. Let me try to answer 2 or 3 different ways. The first thing to think about is that let's just talk about RF planning. So assigning the optimized channel and power, basically avoiding interference. So for that, what you need to understand is that what is the characteristic of the device. And the fact that it's a Bluetooth device from specific vendor with specific model is not as important as identifying that's a Bluetooth device, because you want to understand what the frequency hopping pattern is, what the energy is across channel. So what the radio manufacturers are doing, and they have done a very good job over the last 2 years, is they have integrated FFT functions into the radio itself. So just for channel and power assignment, it's enough to be able to identify what the FFT duty cycle is across different channels. It is not there's no need to have dedicated radios that allow you to identify that it is this Bluetooth, it's this baby motor, it's this microwave with this model number. The second thing is that your mitigation will be different, whether it is an interferer that's frequency hopping across the whole spectrum, or which is like a Bluetooth, or it's an interferer like a baby monitor that's operating only the upper uniband. Most of them operate the upper uniband. So in the second case, you can actually avoid those channels. In the first case, what you want to do is you actually want to be intelligent on how you transmit packets, because while you avoid those interferers. Those are kind of things that we do. We identify the class of device and take the right mitigation techniques. Yes?
I have a follow-up to that. So spectrum analysis is one of those things that I love the integrated feature, and I think it is becoming, table stakes within the industry. But there's fundamentally two different approaches, and I think it has a big impact to how network administrators get visibility into their network and to the performance of their network. And I think that has to do with whether or not you can serve clients at the same time as doing spectrum analysis. And the way I see it, in my opinion, has always been, and I'd love to hear your opinion on it, is that if I can get spectrum analysis while I'm serving clients at the same time, it gives me visibility into the network 100% of the time. And so if an interferer comes up, I can historically report on it. I can know when things are happening on my network. I don't have to wait for symptoms and problem calls to come into my help desk to try to say, well, we might have a spectrum problem. I need to stop serving clients, put the AP into spectrum mode, and then go look for it. Whereas if it's always on, and I can just go look at the report and say, oh yeah, we've had some reports. Maybe we just need to set up an alert for this now, because it looks like it's a chronic problem that's happening regularly every so often.
Well,
so I think that being able to serve clients and do spectrum analysis for an administrator is a big deal, because it's just how you manage your network and how you can maintain performance.
Additional thing, being able to do that accurately is important, right? Because if I've got, if I'm looking at a list of interferers and I see, 5 Bluetooth devices, I can understand that, those are going to be transient devices moving throughout my network. If I look and I see 5 Xbox controllers, that's an entirely different problem, right? Those devices don't belong in my infrastructure. And so being able to, have the fidelity to say, they're not just frequency hoppers, because, then I can go avoid them. But hey, you've got somebody who threw up an Xbox and they're playing on the projector and they're, doing whatever. They're both frequency hoppers, but you need to be able to understand what those are.
Yeah,
from an
what
administrative
type of
perspective.
interferer it is. I agree with that.
You bet.
Yeah, so just to kind of, I agree, Andrew, actually. There's a class of spectrum management functions that will be available active all the time. That is identification, and using the identification to do your mitigation techniques, like avoid the channels or change how you transmit. That has to be available all the time. And then there is a class where, in this example, where now you want to say what kind of interference is going on for a long time, what kind of interference, then you kind of take one of your radios and put in spectrum mode so that you can get deeper analysis. Kind of makes sense.
But that has to be an active thing. You have to have the trouble ticket established in order to do that.
Yeah.
The
So
system's not going to serve you with the information automatically.
Yeah, so one of the things that we do, I don't know if you're familiar with adaptive radio management, one of the things that we did in adaptive radio management was the idea of dynamically taking a radio and deciding whether it's an access point or a monitor. This was, in the old days when radios only gave you access, it was more of an IDS function, not a spectrum management function. So one thing that we are looking at is we're looking at exactly something similar, saying that when a persistent interference is identified, can you automatically integrate that into ARM, which will be the third mitigation technique. The third mitigation technique will be to take the closest radio and put it in spectrum mode and change so that will kind of reduce the coverage. So change your neighboring radios, increase that coverage so that you don't affect the clients. And then you can get deeper analysis into the spectrum, and then you can identify interferers.
So I guess I understand, the ARM benefits of maybe having the automatic mitigation, with the spectrum analysis, but I still think you're losing that visibility as an administrator to understand why things happen the way they did. I mean, maybe you're, sending alerts or logs or something, say channel change from 1 to 6 because we detected some interference on channel 1 or something like that. But still, it doesn't give me the data to go back and verify it, because I think a lot of
in the AP
detection capabilities in spectrum analysis, it's imprecise, and it's more of an art than a science, I think, when trying to detect some of those types of interferers, and having the raw data behind it as an administrator is golden to be able to, human analysis you can't replace human analysis with computer analysis all the time.
Yeah.
I think there's some level where you need to have that data behind it to be able to go back into and verify. And I don't know, I fundamentally, don't understand the concept of going with the Wi-Fi chip spectrum analysis when fundamentally that's not what it's designed to do. Even if they are building it into the chips, I still feel like, you know, you're losing a lot of capabilities trying to do it that way.
And I think another point on that is that what you had mentioned, that, okay, we'll automatically switch one of these APs over into the monitor mode.
Spectrum mode.
Spectrum mode, we'll power up the neighboring ones. That sounds great in paper, but that's gonna be crap in production.
No,
Because
that's
what happens when an AP fails, that was one of those neighboring APs, and now you automatically move this one over to do the spec am. You've adjusted all your dynamics. So a separate chip is key to be able to do both things at both times.
So let's see how technology has evolved, right? Maybe 4 or 5 years back it was key, but now if you look at the AP13X access point, so AP13X access point, you can put it in spectrum mode, you can get raw FFT, so that you can do your human analysis. So the point I'm trying to make is that technology will evolve and it will get integrated, because that function is required to do DFS operation. Without that, you can't do proper DFS operations. So you cannot be regulatory certified. Your radios cannot be regulatory certified to operate, to do Wi-Fi. So our latest access points actually on the same radio, if you put in spectrum mode, you get complete raw FFT.
Yeah,
So
I
you can-
guess my point of contention is spectrum mode versus client serving mode, and I would like them to be concurrent rather than one or the other.
Yeah,
I think the whole concept of AP modes is outdated and needs to go away. AP just needs to be operating and needs to be able to do everything concurrently.
So that's our philosophy, right? That's why 13X access point does both together. 105 access point does both together now. So we are saying that it actually has become a pervasive thing in your network. It is not a tool that you send somewhere. That was 5-6 years back, like Microsoft, right? So when we first won in 2005, so one of the things that they talked, in 2005 the point was, if there is some, if I remember, a European country where a branch office had some spectrum issues. So at that time what they would do is they will actually take a spectrum analyzer, ship it to that office, they'll plug in and then they will debug the problem. Now it is not like that, it's completely integrated into the infrastructure.
I think partly one of the confusion was, I don't think that everybody got the fact that 135 and 105 actually looks at spectrum and serves clients at the same time.
Yeah, yes, so I actually assumed that, I just assumed that was.
Oh, no, because I'm coming from, you know, a perspective of where the industry's been previously, where based on the Atheros chipset, there were 2 different modes in the AP, and you had to turn off client server to do the
Yes.
spectrum. And you're saying that's not the case in these.
Not anymore,
Okay.
not anymore. That's the beauty, right?
So can you
Yeah.
look at, you know, the raw FFTs without switching into a new mode?
Raw
So can
FFT,
it do
Yeah,
both?
so we actually have something called hybrid support, hybrid mode support, which is exactly what Andrew was referring to, where you're serving clients and the FFT is being captured. The only problem is you're capturing it on that channel.
on the channel that you're in.
Right.
As opposed to
Right.
the entire spectrum, right? So if you want to get the entire spectrum, you kind of need to hop back and get into the
Put in
whole mode.
similar to
But
the-
in reality, the thing that you're interested in is whether the channel you're operating on is being interfered or not.
Right,
So
right.
hybrid mode actually
Yeah,
is
fine.
great.
Yeah.
And to
In a lot of
troubleshoot that
cases.
channel from a
Correct.
raw RF perspective.
Right.
while
The
you're
only
still
only
serving
challenge that
clients.
comes across is when you have wideband interferers. Classifying those requires you to kind of take a step back and look at the whole band.
So that's the thing, right? So that's when you want to do deep classification,
Right.
you need to put that device in spectrum mode and do deep classification.
Is this an inline posture, or how does that impact,
Yeah.
let's say, performance?
It doesn't impact performance. That's a good thing about it, right? So basically, if you look at the process of spectrum, Pradeep referred to fast Fourier transform. That's kind of what you need to do. It's built into the chip. It's a few gates. Initially, it started off with a separate chip, and then as technology progresses, you get better and better semiconductor technology. You just integrate the gates into the chip. That's it.
What kind
So-
of fidelity are you getting out of that, though? As I understand, when you rely on a radio to do that, it's a very, very coarse dissection of your noise floor.
No, so the first generation was an 8-bit FFT, which is okay.
8, you said?
Yeah, 8-bit. These days we are doing 16-bit, which is pretty decent. You get enough samples to be able to give you a sense of how the signal, is looking like.
And compare that to a dedicated spectrum analyzer.
Beyond a certain point, it's Nyquist, right? You don't really need the points. You're just wasting
I
it.
disagree, because at that point you're getting into the conversation of, is this a legitimate Bluetooth device or is this an Xbox
Fair,
controller, right?
fair. So the question then is, ultimately it comes down to power budgets, cost, and things like that. Yes, we can definitely put an ASIC on the side, an extra radio, if you will, to kind of capture the spectrum, give you more detailed analysis. But what does it do to the cost curve of the access point? So if you integrate it, you essentially are running the cost curve. We want to leverage the commoditization to some extent that's happening because of the retail market into the enterprise, which is kind of what has happened over the years. Once you go away from too far away from the reference designs, you end up basically not being able to take advantage of the cost curve.
Sam, this
So-
is where I think, there's still a point or a place for a dedicated spectrum analysis that runs on a tool,
Right.
on a laptop, or something, where you get the most bang for your buck at the cost and the price point that customers are willing to pay for, and there's like a diminishing returns after that point, and I think that's where this place still exists for. Okay, well, how often do you need to do the detection between Bluetooth and Xbox?
No,
And if it comes up and you need to, is it more cost effective to have it built into every AP, or to send somebody out when that happens with a laptop?
I'll give you a real example, right? So the price difference would be a $700 AP versus a $1,300 AP.
And you also have to think about the POE budget.
List price, right? And
And
of course,
POE.
assuming you fit into the POE budget.
Yeah.
So your competitors are doing it in class 3 PoE today, right?
Yeah,
And
I think
so-
POE is less the issue. The question is the cost, right? Ultimately, you're adding more ASICs, stepping away from reference designs.
Well, and I think that's what everybody here would like to see, right? Is we would like to see innovation at layer 1.
Yeah.
Right, and today you guys are writing reference designs. You guys are riding the wave of reference designs, right? You guys are using. the
But
same
if
thing
you
that
think
everybody else
of
is
the
using.
innovation that actually happened in Atheros, I mean, them putting the FFT, it was actually a result of us working with them 36 months ago. Putting
was-
FFT. In
yeah.
fact, I'll tell you a little bit of kind of inside story on the industry, if you will. Cognio was the company that was kind of doing this, right? And they were on the market. They wanted to be sold. We went through a lot of analysis at the time, and we actually came to the conclusion that customers will not pay for this in volume. It's a nice feature, but it needs to be something that it gets integrated into the chip. The analogy that I make, if you go back to the wired side, Armon, when we initially built switches, Armon was not in the switching chips. So you put a span port, you plug an Armon probe into the span port, you get your layer 1 through 7 analysis. What ended up happening was, over time, layer 1 through 4 Armon got integrated into the switching chip and started to give you a lot more information about flows and so on that actually went through the network. And then when you need the exceptions, then you use the probes. Same exact scenario here. Layer 1 innovation, as it happens, working with the manufacturers to get it into the volume products is really what is needed, right? And so that's kind of what we are trying to do. The next area, frankly, is location, where we still rely on sort of the standard RSSI-based metrics to figure out triangulation. But what can you do more? Can I get better fidelity on the signals so I can do better time distance of arrival measurements, for example?
But I think
right?
there are some fundamental flaws in relying on noise floor to do spectrum analysis, right? Well, what if you're under a jammer attack and you're not receiving signal at DAP? Your noise floor goes away, right? You lose that fidelity under some of the most extreme attacks from an IPS perspective.
No, so noise floor only matters when you're picking up a signal in terms of decoding the modulation and trying to make something of the data. When you're doing an FFT, you're really capturing the spectrum and trying to put them in bins and figure out what the signal actually looks like and then classify the signal. So they're kind of, so signal to noise ratio matters when you're really trying to recover a packet from the air, right, as opposed to just doing FFTs.
So if you're not receiving signal into your AP, what you're saying is you're still doing noise, you're still doing spectrum analysis?
Yeah, FFT is always, we're always detecting energy.
FFT is always coming into the.
We have to, that's a base for everything, right? And once the energy starts to pick up, we then try to figure out what is this energy. Is it a packet? And then demodulate it and take it all the way through the Wi-Fi packet chain? Or is it some noise that I'm hearing that I'm just trying to correlate and figure out what else this is, right? And there needs to be obviously some SNR to be able to even detect that it's energy and not below the noise floor. That, even having a separate ASIC is not going to help you. It's really a function of the radio, receive sensitivity, and the noise fidelity that you have on the access point.
I've got a question then. I think, we have talked with, for instance, like Keith Parsons about, how AirMagnet does it with, Wi-Fi adapters and how they lose the raw RF energy and it comes through, you're getting the data after it's been processed by the driver and you've lost that raw RF energy. How is the architecture that you've worked with Atheros in your APs?
No.
Are you getting the FFT right off of the?
It's not like doing FFT on a PC platform where you have to write off the driver. Of course, exactly. We actually have access to the raw instrumentation on the hardware, and that's what we use to get the FFT bins and then kind of decode.
What Sam was alluding to is like I have an air horn, for instance, right? or a jammer, and if there's no Wi-Fi packets being transmitted because there's a jammer or something like that,
Doesn't get to your radio.
if it's already like on a laptop-based adapter, you don't get any noise floor, you don't get any information then because there's nothing being received, and so it has nothing to base a noise floor off of, right?
The software hardware architecture is very different on our access points than what you see on traditional laptops.
That's the advantage of AP
Yeah.
hardware is we can actually be a little bit more careful of, for example, the receive sensitivity logic on the board, the transmit power logic on the board, and things like that, right? So that's fortunately the reference designs give you a little bit of leeway in terms of how you design the radio front end piece on the higher end access point. On the lower end access point, it's sucked into the chip, so you really don't have much of a choice there.
So how do you determine what's noise and what's not? Is it based on a preamble? Like Airhorn sends a preamble, right, Andrew?
It's Wi-Fi modulation. There's no bits encoded
There's
or
no
anything
bits,
like
right?
that.
You basically, preamble is the detection of a Wi-Fi packet, right? And for that to even happen, you need some acceptable margin on SNR, right? Assuming SNR is a little above that and you're starting to look at this, you pick up a preamble and say, yeah, I got it, it's a Wi-Fi packet. You lock into it and then start to receive the rest of the packet.
So there are two types of there are two ways you detect Wi-Fi signal. So at the end, the radio is running something called, maybe we are going too into detail, but the radio is going to something called
No, this is the detail we want to go in.
So radio is doing something called clear channel assessment. So radio is constantly trying to figure out if my channel clear, there's something that's of interest. This is independent of FFT. FFT is a completely different chain. Let's just focus on .11 packets. So clear channel assessment has two algorithms. One is called the energy detect threshold. Another is called carrier sense clear channel assessment. So carrier sense clear channel assessment, if it is enabled, anything that tickles the hardware, it will try to decode. And energy detect clear channel assessment, you can specify a threshold that says that if the energy is above this threshold, then you will go and try to decode the packet to see if it's a Wi-Fi packet or not.
Thinking. I guess I'm still somewhat unclear about where the FFT happens in the radio itself, right? If you've got
There's basically a block of logic. So as RF energy is detected, some of it goes to the Wi-Fi logic, the receive logic, where you're detecting the preamble, and then the same signal is copied onto the FFT logic, and there's a separate sort of pin, if you will, that the software can read from, which is the FFT of the channel.
So it's not interpreted anyway, the raw.
Yeah, it's not interpreted anywhere. It's just the raw FFT that you get, and instead of going through the Wi-Fi detection logic, and it's all in the same chip. It's just different set of gates.
Do you have block diagrams of the radio designs?
Yeah, actually, if you go to Ethero's website, they may actually have some of this, but if not, we'll try to make those available to you.
Okay. And then I guess the last question I have is, when you talk about FFT modes and all of these layer 1 functionalities, what are the costs associated with that from a controller capacity or from a licensing perspective? Do you pay any more in order to get that across your infrastructure from an AP modes perspective or from from any perspective?
No, in fact, Spectrum is the hybrid Spectrum mode is built into the AP. I mean, if you're operating as an AP, you're getting the Spectrum piece. The licensing probably is more on the visualization aspect, the software
And
visualization.
what are the costs for that? Because if I want FFT visualization throughout my deployment,
Yeah.
pervasive, right? What are the costs associated with that?
I'll need to get somebody from product management for that. Can you?
Yeah, it's
Or if you have the
basically
answer, go ahead.
RFP, there's the RF Protect license, which turns on the advanced IDS and IPS besides the rogue AP detection and containment. And then it also turns on the Spectrum. So it's something that you install on the controllers for all their APs in the network, and all of the APs in the network become Spectrum capable from a visualization perspective. They're always capable of Spectrum because of channel changes and power changes.
This is one of those things. We didn't add another license for Spectrum. It is bundled into the RF Protect license for the visualization. So if you have RF Protect, which a lot of customers do, they already get it. If you don't, and you need to purchase RF Protect, don't quote me to it, but my guess is I think about $100 an AP is kind of what the.
And that applies to 100% of the access points on any controller?
Yeah. You basically buy the AP. I mean, so if you're interested in the monitor mode kind of thing, I just want to deploy a few Spectrums. You don't need to buy it for every AP. If you want it on every pervasively throughout the infrastructure, you buy it for the controller load, how many ever APs you might have.
I think the important point there as well is that there's a base level of that functionality that you get with the with ARM in the base system. You don't need to buy an extra license for that. It's actually extra stuff that you get.
So this is the cost is $70 extra per AP average.
I guess back to virtual.
Back to virtual controllers. No, that's interesting actually.
So one point I did want to make, I mean, during the discussion, we spoke a little bit about band steering and load balancing and airtime fairness, etc. The next set of innovation in this space is going to be application-aware RF management. Actually figuring out, is this packet I'm about to transmit, what stream does this belong to? And then what kind of rate adaptation or what kind of modulation should I put on this particular packet? That doesn't happen today. The rate adaptation algorithms are optimized for a certain set of assumptions, which is I'm sending data traffic, I'm going to try to burst at the highest speed I can, and if I can't, then I'll try to retry the packets. The rate adaptation logic, I think, over time is going to evolve based on the application payloads that we're beginning to see. So watch for the space from an ARM evolution and innovation standpoint. That's what we'll be looking at.
Yeah, the way you handle a voice packet is very different than the way you handle a video packet.
Yeah.
It's very different than the way you handle a regular data packet.
Isn't that already kind of included if you're doing QoS and
There's a
queuing?
We do scanning, right? We actually optimize scanning.
Prioritization and rate adaptation are very different things. Prioritization is just.
I get that, but can't you just tag rate adaptation to the access category in the queue if you wanted to do it differently?
You have to make your rate adaptation algorithms application aware, and that's the kind of the next area of innovation that you would do.
And are you saying that queuing the 4 access categories in Wi-Fi, for instance, aren't granular enough to do that, or you want more granularity than the queues give you?
No, the queuing just tells you it's higher priority, but when it actually gets down to determining what data rate I want to send this packet at,
okay.
right? Am I sending it at 300 meg or 200 meg, right? That's a real-time decision that you need to make based on the channel condition. And if you're video, or voice, you don't want to do retries.
Yeah, but voice has its own queue, right? Video has its own
No,
queue.
even
The queue is only controlling your distributed coordination function, right? Queue is just deciding what your contention window is going to be, so that if you have a packet which is in the best of voice queue, it just goes out. So this is actually before you queue a packet, because when you queue a packet, you have to decide what rate hardware should transmit it in. And before you queue the packet in the voice queue, you might want to run a different algorithm if it's a voice packet or a video packet, because video packets will be much higher throughput packets than voice packets. And then your data packets. Because for some applications you want to be, you want to get the best throughput. For some application you want to minimize packet loss. And you minimize. Back to VC. So I think back to virtual controllers. So I think what I want to talk about just the architectural system and just maybe go through some of the features that we have built. And so the first thing is we describe virtual control architecture as a decentralized self-organizing system. So what does that mean? So the idea is that administrator doesn't have to select which access point should take the virtual controller operation. You plug in the first AP, it comes up and tries to find the virtual controller. If it cannot, becomes the virtual controller. You plug in the second AP, it comes up, because now the virtual controller starts to identify itself as the virtual controller. Plug in the second AP, it finds the virtual controller, automatically joins the network, registers download configuration, upgrades its image if it's out of sync. So when in steady state, there's only one access point that's actually saying I'm virtual controller, I'm virtual controller, I'm virtual controller. The advantage of that is that if you think about the compute load is exactly the same if you're running a 1 AP network or a 30 AP network in a single virtual controller. Another kind of a very important concept is the concept of a virtual controller IP address. So I want to kind of go back to when we first built controllers. Before that, what used to happen is that administrators had to physically go and manage every access point. So what controllers did was they kind of took the management domain, in addition to forwarding and radio management algorithms, and they expose a single interface, which will be the loopback interface of the controller. The administrator just goes to the controller and he gets a view into managing the whole network. So we do something very similar with virtual controller. So in the virtual controller system, there's one IP address which we call the virtual controller IP address. Think of it as a static IP that is assigned by the administrator to the network. all the other APs can be DHCP IP. But once an AP becomes a virtual controller, it actually assumes the identity of that IP address. So by assuming identity, I mean it will kind of bind one of its shadow interfaces to that IP address and generate gratuitous ARP upstream, that your upstream devices will start forwarding packets destined to that IP to the virtual controller. So this kind of an architecture, so then this virtual controller IP is your single interface for two things. One, towards the administrator for your UI, CLI kind of thing that I was showing you. In this example, 165.1 is the virtual controller IP address. And then for the access points, it kind of provides services that a traditional controller provides, which is configuration management, image management, radius proxy services, centralization of VLANs, consistent policy enforcement. All those services are provided by the virtual controller. There's a set of software that does these services, becomes active on the virtual controller. And the other advantage of having an IP that dynamically binds, a static IP that dynamically binds to the virtual controller, is that if your virtual controller goes down, then what happens is all the APs go through a selection algorithm, a new AP becomes a virtual controller. So if you have a 30 AP network, you actually have 30 points of failure, because you can just, virtual controller, as it goes down, another AP becomes a virtual controller, starts advertising services, and when this AP comes back up, the AP that went down will connect to the virtual controller. So that's kind of, the virtual controller IP is a very unique concept that we have built. So I can give a quick demonstration of, if you're interested, shutting down a virtual controller and we can see what happens.
Can you give us that list again of the functions of the virtual controller? You just had the list.
Yeah, sure. Yeah, so so think about it from first of all, let's talk about first from the administration perspective. So administration perspective, it is the point where you're running your web UI, running your SSH sessions. That is the virtual controller is the one that is talking to your management system. It is exposing SNMP interfaces. It is actually talking to your airway management platform. It is the one that's doing captive, it's integrating with external captive portal, Amigo pod. Now let's look at it from the access point perspective. Access point, virtual controller is the one that is making sure that your images are in sync, because you don't have to go upgrade every AP at the same time. You just go to the virtual controller, upgrade it will upgrade the network. And if you plug in an AP with version X and your virtual controller is running version Y, the AP will automatically upgrade to version Y. It is the point that does configuration management. So if you, when the first AP comes and joins the network, it will download the config. Any config change that is made by airway management system or the virtual controller UI is propagated. Radius proxy service, I think we'll talk about that in detail. We do radius proxy, and we do a radius proxy very interesting way we do radius proxy. It is the anchor point for what we call virtual controller assigned networks. So I'll kind of talk about that as well. So there are a lot of functions like this that the virtual controller does.
So the compute load you said is pretty much the same for that for the virtual controller AP as well as an AP that's not a virtual controller, or so those control functions that you centralize in that one AP. What's the percentage increase in load that you put on that AP?
Oh, that's a good. So good. That's a very good.
It's a scalability.
Exactly, that's scalability question. That's why I was taking the example of the way we do heart beating, right? So the way we build the systems, and I'll talk about it. For example, I'll take the example of dynamic radius proxy services. So the additional load on a controller is not too much. It's not. Additional memory usage on the virtual controller is not too much, because that's what allows us to have a set of like-minded APs and anyone adopt the virtual controller function. So maybe I can give a quick demo of what happens when you shut down the virtual controller. So as we can see, 5.150 is the virtual controller IP address, and the access point with IP 5.54 is the virtual controller. So what I'm going to do is 5.54 is this Ashish Cube AP. So I'm just going to reboot this access point. Basically, I'm rebooting the virtual controller.
Yeah, Ashish is going to be happy.
This is the POC lab network. So I think I'll reboot AP. There's one live network and one kind of a lab network. So as soon as we start the reboot process, what's happened is that all the access points which were listed. Yes, please go ahead.
So if you're connected into an AP that's being controlled by the one that you just rebooted, have you just affected, how are you maintaining a connection to the AP that's rebooting the other one if it's being controlled by the other one?
Right now, I was actually not connected to this
Oh,
network.
okay.
So I'm just connected to my corporate network.
I thought you were basically disconnecting
No, what I did was, I'm connected to my corporate network.
Oh.
What I did was I selected the virtual controller and I rebooted it.
Okay.
So with that, what happened is, as soon as I rebooted the virtual controller, all these APs went to an election algorithm, and a new AP became virtual controller. And it assumed the identity of 5.150, so the network is back up. And if you remember, Ashish AP was the virtual controller. Now we can see, so .55 became the virtual controller. So 55 is the POC lab AP.
Do
So-
all the APs have to be trunk ports then? Because if your virtual IP might not be in the same same subnet as, so if your APs are just come up wherever because of just whatever XYZ DHCP network and then your virtual IP address. So if you're on a 192.168.1 network and you're going to have your virtual IP be a 2 network, is not
So
you have to be
yeah, so
trunk set.
the requirement is that the virtual controller IP and the access point IP addresses are on the native VLAN for the upstream switch. So we don't want to configure VLANs on the access point. So we do it on the native VLAN. So you can configure you can change the upstream switch to configure the native VLAN appropriately. Does that make sense?
It does. I guess I'd like to go back just a little bit. When
Sure.
you talk about APs coming online and first AP up becomes the master, what's that discovery method that your slave APs, if you will, use to join that master? Is it a layer 2 broadcast? Is it a...
So the virtual controller election algorithm is running in layer 2. It's a layer 2 broadcast.
Okay. So your management IP addresses should all be in the same layer 2 network?
That's correct.
Okay.
Yeah, so it should be on the same native VLAN. So the way the virtual controller system works today, all the access points that connect to the virtual controller is the same L2 network. So this kind of an architecture kind of allows you to have multiple points of failure. So the administrator doesn't have to select an access point as a virtual controller or the master or the backup master or anything like that. Just if you have n APs, you have n points of failure. You're thinking about something, Blake. I can sense it.
Cameras on? I equate it back to the days of
Layer 2.
blue socket controller where now all my APs are on the same network and we go out to customers and say that if you're going to use a controller, the beauty of it is that you can just slap an AP any port that you want and it's going to come back and it's go up there. So now if we want to do this, now all of our APs are back onto a management network that we've got to set up a new network just for these APs to live on. And I guess my personal opinion, take it or leave it, is that
Yes.
I disagree. I don't like it.
I think this is very small deployments is
Yes.
where this is focused
Small
at,
buildings,
right? It's
small-
like
Yeah, it is when you're deploying a store, right?
Right.
If you have like 1,000 stores across, you're deploying every store, then you can run a virtual controller network everywhere. And that's what Kirti was alluding to. So the way you extend it, you can extend it 2 ways. When you want to get multiple wiring closets up, you can put a controller, and then your access points will discover the controller and you will have a centralized mobility anchor.
Yeah, no, I see that. I just still think that even in a smaller store environment, now we're overly complicating the network by having to put in another subnet into this for an AP management, possibly. Depends on how your customer wants to look at it and how they want to deploy it from a security standpoint.
Yeah.
I'm sure Rocky would have some fun with me from a security standpoint on the APs if they should be on their own network or not on their own network, even on the controller infrastructure.
Well, I see that actually more as a management concern because the data is going to get moved back.
I think it has a lot to do with your environment because there can be a lot of other things going on, like how much broadcast, multicast traffic you have going on,
Yeah.
how much other traffic does the AP need to process, and things like that that aren't
Yeah.
addressed to it.
Yeah.
There's a lot of other considerations, security, performance. My bigger.
So that is an administrator's choice, right? And that's something that you have to think about.
Yeah.
If you don't have a centralized mobility anchor, if you have a centralized mobility anchor, then you don't have to think about all this.
Yep.
That's the advantage of a centralized mobility anchor, right?
And how
And as Aruba, I just want to make one point. We are not religious.
Exactly.
about this. We want to offer both. Have the
We will let
both
customers
ways.
decide. So we've talked about for last 10
Except
years.
for with the separate
We have no
spec and
religion.
chip.
I'm sorry?
Except for with a separate spec and chip, you're kind of dictating that you
Kinda
believe the
mainstream
reference
it.
device is, the reference chip and using it that way. I mean, we can take that.
Oh,
off.
you're saying that's religion on the spectrum discussion.
You brought it up. I had it posted there.
Right? I could build a Xerox array and price it at $5,000.
Touche.
We will sell 100 of those. We won't sell whatever 100,000 of those.
I have a question on the instant is how many APs can be in the one group? Because I think from a large customer that has a large amount of distributed sites that are actually fairly large, remote sites, that becomes a problem. Then I understand I might be the outlier case, but how many APs can be supported?
So today we actually support 16 APs in a domain. As Kirti was alluding to, the interesting thing is not access points, it is actually users that we have to think about, because it's easy for us to scale access points, make it 32, make it 64 if you want.
Even more making my point, because we're coming in with more and more users with mobile devices and things like this, and I mean, talk any environment you want, healthcare, education, retail, we're going to get slammed with more users. And so
I agree.
Yeah.
I think the scalability is only going to become more and more of an issue, and so I'd love to hear your plans on where you're taking that scalability.
Exactly. So I think we are constantly looking at increasing the scale of a single virtual controller system, because AP capabilities are evolving, right? So when we first built Instant, for example, we built it as a reference for the AP9X platform, which it supports, which has a 64 meg DRAM. Now it supports the 105 and the 135, which has 128 and 256 meg DRAM. So logically, you can assume that we can scale it higher in a single cluster. And as Kirti said, across clusters we will do L3 mobility, because we have no religion, right? We'll let customers decide what they want to do. But the interesting thing that we have to think about is that in terms of distributed and centralization is the number of users that you want to put in the broadcast domain. That is the thing to think about. Because Wi-Fi, you cannot put 10,000 users in the same broadcast domain. Because you have to make some choices, because broadcast multicast bandwidth on Wi-Fi is limited. And the background ARP, DHCP, MDNS, and we constantly build software to kind of become protocol aware and convert all that to unicast, even video. So we have some technology to do that. So in terms of scale, that's what you have to think about. You have to think about, we give the choice to customers. They can decide how many users they are comfortable putting in the same broadcast domain.
What protocol are your APs using to talk to each other? Is that a proprietary Aruba protocol?
Yes,
or
it is a
standard CAT-WEP, or is it?
It's a proprietary Aruba protocol, what we call PAPI.
Pradeep, I have a question.
Yes, please.
You mentioned that the VLAN that the instant AP is connected, the native VLAN, it doesn't have to be created just for the AP. You can use the existing VLAN.
Exactly. So that's what Andrew was pointing out, right? That depends on your network design. If you are comfortable putting APs in the native VLAN, you can. We have a firewall. We can actually protect the Ethernet interface very well. So even if you have a lot of traffic, it's not going to bring down our access points. So you can put it on the native VLAN, or if you choose to, that's a management question. You can. That's what Rocky was saying. You can put it on on your management VLAN.
So Pradeep, we have 10 to 15 minutes if you want to focus on the things.
Yeah, sure. Maybe let me talk about, maybe try to answer your question on scalability. So radius proxy. So the traditional way to do, so controller provide radius proxy functions, so you can have the controller IP as a NAS client, right? So we do something very similar. The virtual controller IP is a single NAS client, and all the APs kind of send radius traffic through the virtual controller. So we did not build a full-fledged radius server, because if you build a full-fledged radius server to do traditional radius proxy, the access point actually has to decrypt the radius packets, then re-encrypt it and send it. So the load on the CPU increases. So we built something called dynamic radius proxy, which the exact architecture of that, what the access point is doing is just doing a dual NAT function. So the packets are well formed by the individual access points, and when it comes to the virtual controller just does a dual NAT, and that does just a very low load on the CPU to do NAT function. That kind of increases the scalability of the system. And the reason we call it dynamic is just because if your virtual controller goes down, new one becomes virtual controller, the radius proxy functions go to the new access point that's acting as a virtual controller.
With Instant, can you still encrypt PAPI like you can with the controller-based
Yeah.
model?
So maybe let me just another thing that I want to talk about is let's talk about content filtering. I just want to give you some thought on how we built it. So we do content filtering with OpenDNS. So the easiest way for us to do it would be take all traffic in SSID and send it to OpenDNS servers, right? But when we started building it, we saw that what happens is that it breaks some things. For example, let's say I'm running an instant network in Aruba, and I enable OpenDNS services for all my employees. I have servers inside Aruba, like intranet arubanetworks.com, builds.arubanetworks.com. I want my employees to be able to reach internal servers, which OpenDNS servers cannot resolve. So what we do is we actually have a split DNS model, where DNS requests from clients that are to the internal server internal servers go to the internal DHCP, internal DNS server, and external DNS requests go to the external DNS server. But it's even more intelligent than that. So now the next thing that we thought about was, how do you identify the domain name? Because the easiest thing to do will be to go ahead.
How do you identify an internal DNS versus an external DNS request without actually doing the request?
No, I'm talking about the clients doing the request, right?
Right. So
let me get to that just a second. I will explain. So when the AP does a DHCP request on the native VLAN, it will get a DNS server address. So the DNS domain name, right? The search domains, and we use that search domains, say that those search domains are my corporate domains.
So only when you're
exactly. And so administrator doesn't have to configure it. That's the ease of use model, right? You don't have to remember and configure these domain names, and we automatically learn that, and then we do split DNS. Maybe another thing that I can talk about is one of the great advantages of a controller-based system is centralization of VLANs, right? So the idea that you don't have to tag your access ports. If you're running an employee, the classic use case, you're running an employee and a guest network, and you want to segregate those two networks because you don't want the traffic to mix. So in the virtual controller, we do something very, very interesting. We actually have a model where you can still create an employee network which is assigned using a DHCP server on the network that we are connecting to, but the guest network can get an IP address from a DHCP server that we run on the virtual controller. So this DHCP server is kind of unique because this is a DHCP server for which you don't configure any scopes. We automatically detect the scope. So if we are connected to a 192.168 network, we will pick a DHCP scope of 172.16. If it's anything other than 172.16, we'll pick 192.168. So the idea that we automatically create a non-conflicting scope, and we run DHCP server on the virtual controller, every AP becomes a DHCP relay. And then we will source net all traffic as it goes out of the virtual controller. So you can actually have a segregated guest network without tagging and creating multiple VLANs on your access port. So that's actually example of how we took virtual controller functions and we integrated into the virtual controller, even though we can't tunnel traffic. The easiest way to do would be to build an architecture that tunnels all traffic to the virtual controller.
And then is it NATing behind the AP?
That's correct. So the virtual controller becomes your NAT anchor, and that NATs all traffic that goes out for guests.
So if I roam around and I'm NATing behind an instant AP,
good call. That's why I said virtual controller becomes your NAT anchor.
Okay, the virtual.
Exactly. So you see that's the other one, because when you do NAT, you cannot do NAT if you're running a flat network. It's very easy to do NAT on the controller. That's why virtual controller becomes the NAT anchor. Oh, I want to talk about over-the-air provisioning. That's actually quite interesting. So what is if you think about any networking device, if you want to bring it up for the first time, you either need a console cable, or you need an Ethernet port. Sorry, you need an Ethernet cable, and you need to know IP addresses, because Linksys devices will say, plug it on the LAN side, go to 192.168.1.1, right? Or you use a console cable, or some devices, what they do is they give you software that you install and they discover over here. So we didn't want any of this. So our requirement was that a laptop which does Wi-Fi, and if you have a modern browser, you should be able to access the network. So the way we do that is, when the network first comes up, it advertises a provisioning SSID called instant, which is an open SSID which is virtual controller assigned. So you'll get IP address from the local DHCP server. But we will configure the firewall rules in such a way that you can only go to the virtual controller web UI. And what administrator does is he opens his laptop, connects to the instant SSID, gets an address using the virtual controller DHCP server, and then we say go to instantarubanetworks.com. That's it. It's a well-known domain name. but every AP knows to spoof that domain name and point to the virtual controller. And then with that, what happens is you don't need any cables, you don't need to know IP addressing, you don't need console cables, and you can do complete over-the-air provisioning. So you log into the network, you create your first SSID, connect to that SSID, and the instant SSID just disappears. So kind of the idea of how we kind of make the bring up very easy.
And you can experience that, of course, with the AP station.
I think we talked about adaptive radio management in detail. Per user firewall, PEF, all the role-based access control, role derivation using server rules, DHCP options, all the voice ALGs that we have are all supported on Instant as well.
So I think currently we have 3 minutes.
Yeah, that's what I'm trying to wrap up actually.
Closing comments?
No, I'll take questions maybe.
Can you talk about mesh creation?
Yeah, so mesh, let's talk about mesh. I think mesh, we saw two things. First of all, identifying what's a portal and a point. So if Ethernet is plugged in and a link is up, it becomes a portal. If link is not there, it becomes a point. The next thing is, if it's a point, how do you do over-the-air provisioning of points? So we have some algorithms to do over-the-air provisioning because we want to make sure that if you, every instant access point is a portal if it's connected to Ethernet, and it's advertising the virtual controller identifier, which is a unique identifier that we generate for the virtual controller over the air. So when a mesh point comes up, it detects all the mesh portals in the air. And if it doesn't have any config, if it's completely factory default, it comes up, it identifies all the mesh portals, and if it sees only one virtual controller getting advertised, it uses its provisioning PSK to download the config to that particular virtual controller. If it sees more than one, then it does not connect. Then the provisioning step is very simple. You take that, connect it to the wire, it will join the domain, download the config, and then you connect it to wireless.
So I have a question. Is there any loss in features on the Aruba Instant compared to the controller-based OS?
Any loss in features? I think if you do a datasheet comparison, of course there will be differences. But if you look at customer benefit for what you want to deploy, like the major things that we are known for adaptive radio management, for use of firewall, role-based access control, policy derivation, ALGs, I think it's very similar.
What about tweaks and changes to ARM for specific clients that you end up having to do with controlling?
If you take an example, I can answer that question. If you take an example.
Intermec devices.
Okay.
They don't
So
like
what is the tweak
default
that you?
DTIM. They don't like the default.
Yeah, so you can configure DTIM on the virtual controller as well. Yeah, and you can configure scanning period. You can configure a set of things that we believe. So the advantage that we have had with Instant is that we have had 8 years of experience deploying large-scale wireless networks, and we understand what are the knobs that are very important, and we expose them on Instant. Maybe any other questions?
I think we're running.
Okay, thank you very much.